So, welcome everyone. Thank you so much for joining us in this year's CU Data Week 2025. My name is Lauren Gunn-Sandell, and I am a research scientist with the Center for Innovative Design and Analysis that is part of the Department of Biostatistics and Analysis in the Colorado School of Public Health. Today, we are going to be having our seminar about advanced data visualization with my colleague Matt Bolt, who is also a research scientist with the Center for Innovative Design and Analysis. And so I just have a few announcements before he dives into the presentation today. We do have sessions for the remainder of the week, and I will put in the chat in a moment the link if you would like to register for any of our remaining sessions. On Friday this week at noon, myself and my co-chair, Samantha Roberts, will be hosting a live office hours. If you have any questions about the material that's been covered during CU Data Week, you can come and ask your questions. We'll do our best to help you. If you have coding questions or more conceptual questions, we are looking forward to being able to help you then. Please stay to the end of our seminar today. I'll be posting a feedback survey link in the chat. And for every survey you complete, you are entered additionally into a raffle for one of our several $75 gift cards. I'll also be putting the Dropbox link in the chat for you if you need to access today's materials. And with that, I would like to pass it on over to our instructor, Matt.
Cool. Thank you for that introduction, Lauren. One question, if I fill out a survey for myself, am I also eligible for the $75 or is that a conflict of interest?
I will have to confer with Samantha.
Okay, yeah, just deflects to someone else, I see. All right, so good afternoon, everyone. By 4 minutes, again, my name is Matt. I am a statistician at CIDA, the Center for Innovative Design and Analysis. Today, we are going to be talking about advanced ggplot2. It kind of builds on the foundation that I presented on last year, which was just regular ggplot2. So we will do a little bit of review just in case, but yeah, without further ado, if I don't get ahead of myself, we can jump right into it. All right, so can everyone see my blue R page? Okay, perfect. I have uploaded to the course site a HTML file of this R Markdown. I will probably keep it on my screen over here, so if I'm looking at it on occasion, that's why. And basically, well, we'll get to that in a second, but I'm going to be reading off of the screen for the most part so that you can see me interacting with R, you can see me interacting with the code. You'll probably see me make some mistakes, which is good because I am not a perfect programmer. But that's how we'll work. If I need to pull up the HTML document on the side, I will do that again. But for the most part, we'll just be hanging out in R today. So yeah, as I was saying, last year's ggplot basics covered simple ggplot ideas and demonstrated how to make increasingly complex, though still relatively simple graphs. This year, I was asked by the committee to go over more advanced ggplot, though advanced can go a lot of different directions. So this session will be kind of a tour of things that some people were interested in last year, some things that I was interested in this year and wanted to learn, and then cover some additional miscellaneous material. I feel like ggplot is kind of like reading. I was trying to think of metaphors for this, and this is the best one I could come up with. Once you learn like the basics of ggplot, you can go a bunch of different directions with it. It's not like hierarchical per se, like math is. You take algebra 1, algebra 2. Once you get basic ggplot, you can go anywhere you want. Just like when you learn to read, you can read whatever sort of book you want. You don't have to read all the books in a certain order. So a couple things that we'll discuss. First, we'll go over my workflow, which we've touched on briefly. We'll do a quick review of ggplot basics. We'll talk about changing colors manually. We'll talk about faceting. We'll talk about Venn diagrams. We'll cover some heat maps, some regular maps. And if I am good with my time, I'll leave a couple minutes at the end where you can ask questions or accusations or any of the like about my coding and ggplot capabilities. First things first, though, my workflow. Right now I'm working in R Markdown. I hope some of you are familiar with R Markdown. Basically, I use Markdown because you can write regular words here. You can put things in italics. Then you can like have little R chunks, and the beauty of Markdown is that when I hit this knit button, it says these fancy computer things, and the dots go to the end and says more fancy computer things. And then it produces this HTML. So if you're not using Markdown, I highly recommend you do so. It's a good way to include both, regular code for me to read and then code for the computer to read. So that's the final product that's up on the course website, or whatever you want to call it. Generally, I will be talking a lot about what's in this box. This box, the environment stuff will show up. I won't talk about it very much. On occasion, we'll use this box here, the console at the bottom left. If I want to do things on the fly and not save them for later, that's where I'll type them. There might be some output there as well. And then on the bottom right here is going to be where all my ggplot output is. Lastly, to run things in R, I use Control Enter. So if you're trying to figure out why things just start running randomly, it's because my fingers are in the background. I will try to highlight things to hit run so that you can see what I'm running, but we'll see if I do a good job of that or not. Okay, so a quick review of ggplot2 basics. ggplot, the command, starts any plot. It's like the fundamental call you have to make. And then the other important thing is aesthetics, represented by AES. These represent elements of your data set that you wish to visualize somehow. So you can visualize those on the x-axis, the y-axis, color, size, shape, all sorts of things. Anything that can be visualized is typically an aesthetic. And these can be applied, aesthetics can be applied at the top of any ggplot function or in the subcomponents of the ggplot functions. I'll show you an example of this in a second. There's also geoms, which are like layers that you can add to every ggplot, which is like the heart of the plot rather than the background. And of course, adding axis titles, legend titles, and changing text sizes. I never remember how to do them, so Google is my best friend. And that's that. So to start off with a key data set we'll review here, we're going to use the data set MT-Cars, and this is a data set from Motor Trend of the Year for 1972 or 74. And it's basically just a lot of data about cars. So I printed the top 5 rows of our data set here. It says what car they're looking at, talks about miles per gallon, how many cylinders there are in the engine, what the engine displacement is. I don't know what that is. How much horsepower there is. I think I know what that is. And just some random car information. And we'll use this to make some plots. This is it's like a built-in data set to every R download that comes with it. So it's a very friendly data set to use for examples. And then we're going to go over the final plot I made for last year. So first, of course, we will load in the library for Tidyverse. Tidyverse has a bunch of different packages, one of which is ggplot2. You could write ggplot2 there if you wanted it instead of Tidyverse, but I default to Tidyverse. And then I'm going to run this function if I remember highlighting things. Okay, we're going to use Control Enter. Sorry. So here, this is like the final plot that we made last year. We're going to briefly go over what all of it means. Really, you can see here, we'll just do the first line. We'll plot only that. This is where the ggplot function that starts everything. ggplot means we're going to call a ggplot object, and then I'm going to say what data I'm using. I'm using MT-Cars for my data set. I'm using the aesthetics of X. I want to be representing miles per gallon, and Y, I want to represent weight. So you can see here on this very basic, very boring chart, weight is now my Y-axis and miles per gallon is my X-axis, though I haven't told ggplot to fill anything in yet, right? It's just setting up the background. So what this next line does, if I just run these 2 lines here, what I'm adding is a geom point. And what a point is, it's like a dot plot, basically. And I'm telling R, okay, we're going to make a point plot. And the aesthetics, I want the elements of my data frame that I want to be represented in this plot. I want the number of cylinders to be represented by color. And I want the number of carburetors to be represented by size. The reason I'm using as factor here is because cylinders is a continuous variable, or R thinks that it's continuous. Here, 4, 6, and 8. So it will try to do some weird color gradient thing. I want 3 separate colors for 3 separate cylinders. So that's why I do that. Then, of course, this next line here, in addition to making a point plot, I'm asking R to, I have the cylinders, and I'm making sure that we're going to group my next thing by cylinder. And the next thing I'm doing is a smooth function. So I want a smooth line for each group of cylinders. And I want those lines, these geom smooth lines, to be a certain color, also by cylinder. And I'm turning off the confidence interval here. Let's see if I copied and pasted correctly. Okay, so we're getting an increasingly complex plot. We started with ggplot, then we added points, then we added a smooth line. Other things we can do, we can add another smooth line for everyone, not discussing groups or colors. Then we add some like labels, like the title, the labels for the color and the size, X and Y labels, and then change the theme and make the fonts a little bigger. And that's our final product. Okay, so I know that was really rapid, a review of ggplot basics, which may not be so basic, but you kind of get the general idea, I hope. So now we're gonna, this is more complex than basic, but we're gonna go back to basic a little bit. And our first new thing we're gonna cover today is manual color changes. So here I have my basic reference plot that we'll use for this for a bit. You can see I call the ggplot function, so I'm making a plot. My data is going to come from the mtcars data frame, which is a great data frame. And the aesthetics I want to represent, the components of this data frame I want to represent miles per gallon for each row with the X and weight with the Y axis. And I'm going to do a point plot. And in my point plot, I want color to be represented by, or I want the number of cylinders to be represented by color. And you can see here, this little parentheses, it should highlight with this little parentheses here, right? So you can see that comma size 3 is outside of the aesthetics call. And this means I want all my dots to be the same size. So like I said, I already ran that. This is a pretty basic ggplot here. And someone was asking last year, how do I change the colors? These are the default colors that R always gives. Blue, green, and pink, pinkish red, salmon, I don't know. They're kind of nice, but you could do better, right? What if you have a theme? Well, what I always like to do, there's so many chats. I'm sorry. Oh, it's all Lauren.
Those are all from me. You can ignore. I will
No,
shout out if there's questions.
So here's a link that I like to use, but I won't use it. You can see my internet now, right? Okay, so we'll just do like R colors. I always click on the first link. It's a PDF document that someone wrote a very nice thing about their collaborator. Oh, a good friend of mine, Dr. Ying, sent me a document. Okay, whatever. I just scroll down right away and find the colors that I like. I am not talented with colors, but let's say we like this dark orchid 4 color. The cool thing about colors is that you can just copy and, we're going to save that for later. You can copy and paste them right into R to change the color. And so similar to this reference plot here, where we have our ggplot and our geom point, we're going to make the exact same plot here with our ggplot and geom point. We don't need theme BW for now. And what we're going to do, we're going to add something. You can ignore this comment for now. Just comment it out. We can use the scale color manual line to change things. So basically we're telling it we're going to pick manual colors for our scale. And this values, you're assigning the values of the different colors that you want to pick. You concatenate the values together, and then you can just copy and paste whatever colors your heart desires from wherever you find them online to change the colors. So I'm going to run that again, and you can see that just by using scale color manual, we have different colors. These are kind of terrible colors. I told you I was not a good color person. This blue one is really hard on the eyes. So instead of cyan, I'm going to do dark orchid 4. All right, that's a little better. You can go whatever color you want. And this is the easy way to do it because you can just look at the colors, and the colors kind of look like what their names are. Sea green looks like green that you would see in the sea. But sometimes you want very specific colors. Maybe your collaborator has a certain color theme for a manuscript or a presentation. And these other colors that you can use in color theory and computers, there's actually red, green, blue codes where each pixel that represents a color has some component of red, of green, and of blue, and they all have special numbers assigned to them. And so these numbers that I've typed in here in advance are kind of the red, green, blue codes for whatever color you may want. So I'm going to run that instead. You can see my plot colors have changed. And again, these colors are helpful if, let's say, we're on the internet and we need red, green, blue colors are. Oh, that's a different thing. Does anyone know what these are called? The hash?
The hex codes.
Hex codes. Okay, hex codes colors are. Okay, so now if you have like one of these crazy things that show all the colors with all the hex codes, you can just copy and paste those and use those for your R colors instead, right? These are kind of fun. Ooh, these have the name and the hex codes. So that's a brief thing on how to change the colors in R, is using scale color manual. You can also do things like scale fill manual. If you weren't using a color component, you were using a fill component, that's for other things. Although it might work here as well. No, that doesn't work here. But anytime you want to change something, scale and then that something in manual is the way to change colors. All right, moving on. Back to our basic reference plot that we have here that we've seen before. Another fun thing you can do, instead of just having all the data on one plot and separating the points by color, is that you can actually facet the plot. And what a facet does is it takes the variable that was by color or shape or whatever it may be, and it breaks the plot into three separate things. So instead of talking, I'll just show you what it looks like. Similar to this call above that made this plot, I basically want each color to get its own plot, and I'm going to use the facet call for that. So this line up here is the same as this line below, you can see. Again, I'm using geom_point, but I'm only picking the size of the points to equal to 3 because I think that's a good size. And then I'm going to add this function call called facet wrap. A little squiggly line here, which is kind of by in my mind. So facet wrap, we want to make all these graphs by cylinder numbers. And then right, I run those again. So what were separate colors are now just separate graphs. And I think it's a little easier to see here. But you can see how this is what our plot looked like before. This red shape was kind of like a weird looking candy cane, if we call it that, and you can see that that's been represented at this left facet now for the 4 cylinders, because the 4 cylinders is represented by red. Green looks like a really weird version of the Big Dipper, which you can see is now demonstrated in this lower facet by 6 cylinders, which makes sense with our green color. And then blue, I have no idea what shape this looks like, but it's also demonstrated here in the faceting. Any questions so far about either basic ggplot, key things I forgot, or colors or facets? No. All right, cool. Well, we will move on to the next thing. And the next thing is Venn diagrams. Everyone knows what a Venn diagram is, I hope. They're like a classic math tool from middle or high school math. And Venn diagrams require a special format for the data. Basically, well, when you make a Venn diagram, let's back up a little bit. You kind of represent two groups, and those two groups, you say if two things are true, or if they're both false, or if one is true and the other is false, or one is false and the other is true. And if that sounds like a bunch of mumbo jumbo, we'll make it more clear in just a second. But you're kind of saying who belongs to what group and who belongs to both groups. And so if you're going to make a plot like a Venn diagram where you're saying about what belongs to which group, so if you're measuring participants, which participant belongs to group A or group B or maybe both groups for some reason or neither group. If you're looking at cars, you can see if cars are fast or heavy or fast and heavy or neither fast nor heavy, which is what we'll cover. But if you're going to do this sort of plot, you need a special format for your data. Basically, to make a Venn diagram, you need 2 or more variables that are just vectors of true and false information. And we already talked about why this is, because the data needs to, the Venn diagram just displays what is true and what is false, who falls into which group, and who does not fall into the other group. So we're going to make some example data to talk about such variables. And as we said already, we're working with the MT-CARS data set for this presentation. So, we have some miles per gallon here. The Valiance is 18.1. The Datsun 710 is 22.8. I want to see which cars are more fuel efficient. So I'm going to make a new variable in MT-CARS, and I'm going to call it efficient. And I'm saying with the MT-CARS data, which is this data set down here, if our miles per gallon is greater than 19, we're going to say true. This car is indeed efficient. I know 22 is or 19 miles per gallon is not great, but it was the 1970s, so we'll roll with it for now. And if the miles per gallon is not more than 19, so if it's 19 or 18 or anything below, we're going to assign it a false label. You could type out, I guess you could type out actually true, and it turns out purple because that's a special phrase in R. But you can also use T-false, which I always use because I don't like typing that much. The other variable we're going to make is heavyweight. So in our MT-CARS data set, we're going to say, with MT-CARS, if the weight is greater than 3, we're going to call it true. It is heavyweight. And if it's not greater than 3, we're going to call it false. And here, weight refers to hundreds of pounds. So this is 2,620 pounds. This one's 2,870 pounds. I don't know why they use decimals instead of just pounds, but it is what it is. So I'm going to run both of these lines of code, and we're going to look at our data again. And we see we have 2 new columns, one for efficient and one for heavyweight. And the Mazda RX-4, because the miles per gallon is greater than 19, it is efficient. That's true. But because the weight is less than 3,000 pounds, it is not a heavyweight car, so it's false. You can see all of these cars have good miles per gallon, so they are efficient, and they have low weight, so they are not heavyweight. Then, of course, you have the Hornet, which has high miles per gallon, but also is above 3,000 pounds. So it is both true for efficient and true for heavyweight. And then you have these other 2 cars that they're heavy cars because they're greater than 3,000 pounds, but unfortunately, they are not hitting that 19 miles per gallon, so they are not efficient. Now that we have 2 columns of true-false data, I'm going to call a new library called ggven. This is like a library that works really well with ggplot to make Venn diagrams. And I'm going to do a ggplot. I'm going to use my data set is MT-CARS and my aesthetics, the things I'm visually representing. My group A is going to be efficient, and my group B is going to be heavyweight. That's referring to these columns here that we made before. And I'm going to make a GM-Venn, which is just for Venn diagram. One thing to note here, you can see I use ggplot2 and then 2 colons next to one another. When you're calling lots of packages, especially when they all begin with GG, it's sometimes nice to label which function comes from which package. So ggplot comes from the ggplot2 package, obviously, but this GM-Venn thing, it plays along with ggplot, but it comes from the ggven package, and I'm just writing that out here so I don't forget. So we're going to run this, and we have our ggplot, our Venn diagram. We can see that in the entire data set, 12 cars are efficient, 15 cars are heavyweight, and there are 5 cars that are efficient and heavyweight. So that's a good thing to know about cars in 1972 or 1974, in case you're looking to buy an old beater. However, this isn't a very pretty plot, so we're going to change a couple things. The first thing we can do is we can change the fill color, and this harkens back to our previous lesson. We're going to use a vector of colors that we want to pick. I thought Fire Brick 1 was a nice color, as well as Dodger Blue. The text color here, I want to be black. The text size, let's bump that up a little bit, 5.8. I think text actually refers to the values in the Venn diagram. And I'm going to set the name size, which is efficient and heavyweight, a little bigger than 7. And then this last thing I'm going to do is another theme call. Theme just kind of controls the theme, as you would guess, of the ggplot. In this case, it controls the background. And theme void is really nice because we don't need like X and Y labels in this Venn diagram. That doesn't make any sense. So I'm going to run this. Beautiful. That is just a publication ready figure about cars from the 1970s on arbitrary parameters of efficiency and heaviness. I'm going to do one more example just to show another Venn diagram. I'm going to remake the efficient variable like I did above here, but instead of 19 miles per gallon, I'm going to pick 20 miles per gallon. And we're going to leave heavyweight the exact same. I really don't need to copy and paste it here, but I am just for completeness. So I'm going to rerun efficient. I'm going to rerun heavyweight. And we can see here those variables are back, good and ready to go. So next from the ggplot package, I'm going to call ggplot. Using empty cars, my aesthetics are the efficient column and the heavyweight column. I'm using different colors because why not? I'm using theme void. And here we see that this number on the bottom has kind of popped up. And this is saying that there is one car who is not efficient or heavy. So it's a lightweight car with bad miles per gallon. I don't know why you would buy a lightweight car with bad miles per gallon. If you're going to buy light, you might as well have fuel efficiency. This is, yeah. But basically, all I'm doing here is demonstrating the capabilities of the Venn diagram to show people who are, or cars in this case, that fall into neither category. The other thing about ggven in the past I've used before, it does more than 2 circles. I probably should have made a different example of that. Actually, we might be able to do an example right now. We're going to say AM. I don't know what AM means, but we're going to say, actually, cars. AM. Okay, it's only 0, 1 actually. So we're just going to make this a true false variable just to demonstrate what lots of things look like. So with empty cars, if else AM, let's say it's equal to 0, or equal to 1, we're going to make it true. And if it's not equal to 1, we're going to do false. And what you can actually do here is you can add another circle using the C. So I'm going to do it AM, and I'm going to need another color for this. Let's steal Dodger blue. Let's see if this runs. Ooh, look at that. We have a 3-circle Venn diagram. You can also do 4 circles. You can maybe do 5 circles. I can't quite remember. But after 4 circles, it gets pretty chaotic. So anyway, we can see that 10 cars are efficient and AM, but not heavyweight. We have 0 cars that are efficient, heavyweight, and AM. What is AM? I'm going to do.
I think it's automatic versus manual.
Oh, you're right. Thank you, Lauren. This is why Lauren's in charge. But yeah, just kind of showing off the flexibility there to put 3 circles in your Venn diagram. Any questions about Venn diagrams before going to heat maps?
There is a question in the chat, and
Yes.
it says, can you make the circles representative of the size of the population within them? Or does that get a little too messy?
I don't know. I will say when there's a will, there's a way. You can always do something in ggplot if you really want to. I have not done it. I would say you could try. That's all I'll leave that with. I don't know if that's the best way to represent data either. Because the overlap, it'd be weird to, like, would the area of the overlap also represent its size? And then, you know, if your overlap is really big and then you have like little things, would you just like have very thin slivers on the edge, or how would that work? Carrie loves a challenge. All right, Carrie, if you figure out how to do this, please send it to me and we can make you do the ggplot presentation next year. But I don't know, but it'd be fun to find out. And is there another question? Okay, Paige was talking about the color palette generator. Okay, very cool. Yeah, if they're prettier than the color palettes I make, that's good. And they probably definitely are, because look at this. That's not any designer's definition of beautiful. All right, on to heat maps. Heat maps are kind of fun. I couldn't remember what sort of data you needed to make a heat map, though, so I'll give a quick reminder of that. For a heat map, you need data with a certain structure. On a heat map, I'm going to just make a heat map real quick so that we can look at it. Okay, so for a heat map, you have like a y-axis and an x-axis. So you need data, obviously, to fill up both of those. But the third data point that you need in a heat map is whatever the color is going to represent. So you have to have at least 3 values for a heat map. And not only do you have to have 3 values, but if the x and y axis are categorical, which they often are in a heat map, or at least continuous throughout, you need a value for every single combination of the x and y variable. And we'll talk about what that means in a bit more detail. So here in this code, I'm setting my seed to 5 because I'm going to generate some random numbers. And if I want to make sure I generate the same random numbers next time, I want to use the same seed. And what I'm going to do here is make a data frame where each uppercase letter is repeated 26 times, once for each of the lowercase letters, all the way down my data set. So instead of talking you through it, I'll just show it to you. What I've done, my first column, I've just called uppercase letters. And I've taken, letters is a really cool thing. It's also built into R. You just type letters, it gives you all the uppercase letters. You just type little letters, it gives you all the lowercase letters. So what I'm doing is I'm taking letters and I'm repeating each one 26 times for my first column. Then for my second column, I'm taking each of the lowercase letters and representing the whole alphabet 26 times. So the first column, I do A 26 times, then B 26 times. And then the second column, I do A through Z 26 times, but not repeating within itself. And then I'm going to make this random number, which is going to be represented by color. So here I'm just using the normal distribution, and R norm grabs some random value from the normal distribution. Since I have 26 uppercase and lowercase letters in combinations, that's how many I need. And I just picked a mean of 0 and standard deviation of 10 for some more variability in color. So yeah, you can see the very top 5 rows or 6 rows of the data set, it's all A, and then A through F with random numbers. And then the very bottom of the data set is all Z's with the last bit of the alphabet here, also with random numbers. I see that there's some chats too.
We have a Venn diagram question.
Oh, yeah.
And I did find an argument where it allows auto scaling in the Venn diagram circles. So that is
For the
possible.
roundness? Okay.
No, that would be for Carly's question about the automatic resizing based on the population within them.
Okay.
But for Guillermo's question, can you make the circles rounder in the Venn diagram?
Yes, you can make the circles rounder. I had to do this recently and it was a bit of a pain. One way you can do it is you can print this if you like. So if we click and drag this here, the circles get rounder. That's not exactly what you're asking about. But if you were to export this image, you could adjust the width. Let's say you want 555. So you can mess with that before you save it. That's the one way to do it, which is kind of like a backdoor hack. It's kind of annoying to play with the different aspect ratios. The other option you can do is there's a different way to make the Venn diagram, which I won't go into in too much detail, but you basically make a list of all the IDs that fall into each category and then build the Venn diagram based on that list. And those puts them out as circles immediately. If you Google, ggvenn, Venn diagram, ggplot on Google and look for the list approach, that will make them more circular too. Great. Sorry, I'm not catching these questions as they come up, but all right. So back to heat maps. We have our heat data, and what we're doing, we're gonna do ggplot. We're gonna use the heat data that we just made up here for our data set. Our aesthetics, we want the x-axis to be representing the uppercase letters. We want the y-axis to represent the lowercase letters. I really missed the opportunity to call this. uppercase letters, but that's okay. And then the fill is going to be that random number. And the important thing about this is we're going to use geom_raster, which is a fun sounding name. I'm going to run that. Ta-da! We have our heat map. Obviously, this heat map doesn't mean anything because I picked random numbers, but it is kind of cool. We can pretend maybe this is the popularity of two different letter combinations. But the blue and the black, it's default and it's kind of difficult to read. It also makes me feel like I'm going blind. So instead of just blue and black, we're going to pick our own colors, which we've done a couple times now. We're going to use scale fill gradient. How do I know to use those words? That's what Google told me to do. I'm going to pick the low color to be yellow and the high color to be blue. So we're going to run that. And that is kind of more fun, I guess. Also, if anyone is colorblind, I'm very sorry if I'm using bad colorblind colors. That's the joy of picking colors. You can pick colors for colorblind audiences. That makes sense to everyone. But I forgot to look that up in advance, and I don't remember what sort of color blindnesses are out there. So if this is terribly...
I'll put a resource in the chat for those who are interested.
Okay, thank you, Lauren. So if you can't see this, I'm so sorry. But yeah, so we can see that here the blue is really high, so maybe the combination of uppercase O and lowercase c is really popular. And then, low score here is uppercase Q and lowercase L. Yeah, it's just made up data, so it doesn't matter. The other thing you can use here is geom_tile. That's another option. It makes pretty much the exact same plot. Just use whatever geom sounds more fun to you. And while I was researching this thing, I was like, what does raster mean? And Wikipedia told me this. In computer graphics and digital photography, a raster graphic represents a two-dimensional picture, which is kind of like our graph, as a rectangular matrix or grid of pixels viewable via a computer display, paper, or other display medium. So raster is just the word someone who built computers way back in the day came up with for this sort of image. I see that we have a few questions. I'm going to try to look at them. Oh yeah, there is a great comment about the C package, colorblind friendly. Okay, excellent suggestion. Am I missing anything? Okay, Lauren's just adding the other comments. Yeah, that's heat maps. I've never had an opportunity to make a heat map for work. I think it would be cool. If you need one and you don't want to do it, ask me because I'd like to make a better one than random number generations of combinations between upper and lowercase letters. But I know they're popular in genomics and stuff, in omics work more generally. All right, the last topic, I know we have 20 minutes left. I'll try to get through this in 10 minutes or so, or quicker, so that if we have time for questions or you want to just ask me to make a totally random plot, we can do that. I use this link. I've never made a map before this presentation, and I use this link a lot to learn how to make maps. The writing style is kind of fun. It's very informative. A quick reminder, too, about geography. The Earth, everywhere on Earth, has latitude and longitude. And latitude kind of tells you how far north or south you are from the equator. In our mind, this can be represented by the typical y-axis. And longitude tells you how far east and west you are. That's a typo. How far east and west you are from Greenwich, England. I think whoever came up with latitude and longitude back in the day probably lived in Greenwich, which is why it's 0. And this is more often used in our brains as the x-axis. And because the United States is west of Greenwich, England, we always have a negative longitude. And because we are north of the equator, we always have a positive latitude. Before we get into the actual map, I'm going to make some example data here. So I'm making a data frame. I'm going to call the longitude these values, different longitude, these values, latitude, these values, and order, which is 1, 2, 3, 4, which is important in a second. So I'll make this data and we can look at it. Basically, before we jump into maps, we need to learn about the geom_polygon component of ggplot. Here we have geom_polygon, and what geom_polygon does is if you give it x and y points, in this case we've named it latitude and longitude, it will draw a little shape, a little polygon, as it were, and connect all those points and fill in the middle. And so we have here with our first plot is just a really boring square. And you can see that because my longitude is 0 and my latitude is 0, GeoPolygon just draws a point at 0, 0. And then my second value is 0, 1. So at an x value of 0 and a y value of 1, we draw another point, so on and so forth. 1 and 1, we go to 1, then 1 to draw a point. And then 1 and 0, we go 1 on the x-axis and then 0 on the y. So we have these 4 points, and it just draws a little square and fills it in. Kind of fun. The order is the order in which you draw the lines. You can imagine if I had a different order, it would go from here up to here, and then down to here, or any sort of variety thereof. So order is why we put that in. We tell R the order of the points that we want to draw. And it makes a little square. My other example here, I'm using longitude 2. And I've made another little polygon based on 0, 0, 0.25, and 1 here. Then 1.25 and 1, and then 1 and 0. So you can draw all sorts of fun shapes, whatever your heart desires if you really want to draw polygons. The important thing about polygons is that based on latitude and longitude, oh, there's some chat. Let me check that.
We have a heat map question, but I think we can cover that after you're done with the mapping.
Yeah, I will come back to the heat map.
Yes.
Good question, though. I like good questions. So what we have here is you can actually download data for latitude and longitude for all sorts of different maps. So here I'm loading the maps package. It's a package with a lot of map data, obviously, like latitude and longitude measures. And from the maps, there's this function called map data. So I'm taking the data for the United States of America from map data and assigning it to US. And then I'm just going to look at the top of the US data set, and you can see we have a longitude measure and a latitude measure, an order. And then there's these other things too. I'm not really sure what these variables are for, but we can look at the tail of this too. This is the bottom 6 rows of the data set. You know, we're still negative longitude, still, I guess it's making a full circle in some sort. Positive latitude, and the order is the, these are all in order so that they draw the lines in order. Let's see. Group might be for islands, I think. If you have lots of different groups to draw, you need different polygons. So what we're going to do quick, we're going to make a ggplot. We're making GeoPolygon. Our data set is going to be the United States. Then we have our X values are representing long, our Y values are represented by latitude, and our group is equal to group. I think the group is for those islands there. Then we're going to use Chord Quick Map. I didn't know what this was before some Googling, but it's helpful for converting 3D space, like our globe, into 2D space, like your computer screen. So for the big reveal, we run that, and basically we've drawn a bunch of points on the XY axis represented by latitude and longitude, and we just drew one very large polygon in the shape of the United States, which is very cool. Now, let's say you actually are trying to present something. Oh, let me check the chat real quick. What's the default coordinate system for ggplot? Do you want to elaborate on that? I think just like Cartesian planes, unless this is like unless I'm misinterpreting the question. Or if I don't understand coordinates. Okay. Yeah, this one's over my head. I'm sorry. I know there's different latitude and longitude. There's like negative and positive, or east-west. I think ggplot here is just using the negative positive rather than east-west. Probably the same for north-south. Okay, cool. Google will be more of your friend than me in this situation. But let's say you have your map, but you want to plot something about it. You want to plot where major cities are, which is what we're going to do in our example, or you want to, whatever you do for your research. What you're going to do is just make data. Here, I've made geodata, and we'll look at it. I've just picked 3 cities I want to plot the locations of. So we have the latitude and longitude of Denver, the latitude and longitude of Phoenix, and the latitude and longitude of Nashville. because all of these are west of England, they all have negative longitudes. And because we're all north of the equator, we're going to have positive latitudes. Now, very similar to our previous plot, um, all this code is the same as this code above here, I'm pretty sure. But then we're just adding another layer. We're going to add a geom point. We all know geom point pretty well at this point. But we're going to use a separate data source. We're going to use geodata, which we just created as our data source. Then we're going to pick lat and long for our x and y values. We're going to make the dots yellow, and we want the dots to be size 3, I guess. We're also going to add, I'll just do that first, see what happens. Okay, cool. We put little dots where these cities are. That's fun. Now also I'm going to use geom text to add another layer on top of my ggplot that already exists. I'm going to use geodata again. The aesthetics are X and Y, latitude, longitude. But the label I'm going to use that geom text is useful for is the name. I'm going to color that yellow, or again, you can pick whatever color you want, hexadecimal code, whatever you want. And nudge X here kind of tells you to move the name around a little bit. So we're going to plot that. Oh, beautiful. Denver, Phoenix, Nashville, the best American cities of all time. I'm just kidding. I don't know why I picked them. Instead of nudge X being 4, I think they're a little too far away. So let's do it at 3. Originally, actually, I was going to pick Chicago, but then it kind of ran off into Lake Michigan and didn't look so good. So that's why you got Nashville and Phoenix instead. And then lastly, this is the same plot as above if I change this, but again, we're going to use theme void to get rid of that background. And boom, you have a beautiful plot. You can impress all your friends with your ggplot capabilities. And that's that. As you can imagine, this would really get intense. You can plot like data that you take on runs. You can use Google Maps data so you can get the actual satellite images of the United States and plot things on top of that. There's, the geography people have gone absolutely wild with plotting maps. This is just dipping your toe into the giant ocean of GIS data. But hopefully it's a nice, simple little introduction. Okay. Are the dots actual dots with a radius that can be defined, or are they a list of points drawn together and filled? I asked this to address scale when you plot, for example, Denver and Colorado. If I understand this question correctly, do you want the dots to be bigger or smaller based on the population? I'm going to assume yes for now. What if we do something like size? Okay, let's say Denver has like 3 people, Phoenix has like 2 people, and Nashville has 1 person. Here in our aesthetics thing, we could do size equals size. Oh, that didn't work. Geom point, geodata. Did I run geodata again? Oh, it's because I'm overriding it here with size equals 3. Okay, so now you can see Denver has a big population, Phoenix has a smaller population, Nashville's tiny. I don't know what the actual populations are. And then, of course, we could hide the legend. I don't remember how to do that off the top of my head, but it would be useful. Okay, Elizabeth asks, very nice. Please show for selecting one state only, i.e. Oklahoma or Texas. For that, you would need to pick from map data something that was not the United States. And when I was making this presentation, I thought about just plotting the largest mountains in Colorado because we're in Colorado and that would be fun. However, it was just a lot easier to find the United States data than Colorado data. It might be in here somewhere. Data. Let's try this if it gives me anything. Okay, so Colorado doesn't look like it's in this package. To answer your question, yes, you could definitely pick a specific state. I just picked the United States because it was easiest to grab for this presentation. But you could do literally anything you want with maps. You can go absolutely crazy with it. I have not for this presentation, but all right, it's 12:51. I think we had a heat map question. Elizabeth, let me look at your picture. Okay, so here you have, you have this data for age group. Sorry, her question so everyone can see. Can you do a heat map of the following table as fake data? I just want different colors based on magnitudes of counts, percentages shown here. Yes, you could do a heat map of this. Can I do it in like 2 minutes? Maybe not, but I can think about it. Um, yeah, I'm putting this off to the side. I'm just gonna see what happens here. So in this case, we have test data. We're gonna have data frame. We're gonna look at age group and ethnicity, let's say. I don't know what's being, is it just percentages that you're interested in, Elizabeth? Like the number of people in each group? I think that's what it is. Um, let's do, okay. The ones in this example are white, black. We're just gonna use three because I don't want to do that many. And then age group, we're gonna do young, middle, old. Yeah, that's every age group you want to fall into, young, middle, and old. Values, we're gonna do R norm. Let's see, 9 values. Equals 10. Test. Um, I don't see why there's any reason this shouldn't work. Maybe because I'm thinking too quickly. Age, not age group. Yeah, so you could definitely make a heat map of this. It's not very pretty the way I've made it. Um, and I think this would be mostly valuable. I assume this table that you just sent me is really just like saying how many people in your sample belong to which groups. There's no like actual medical values in here. There's no height or weight. You're just saying of our sample, 559 were aged 10 to 19, happened to be white. Another 72 were between ages 10 to 19 and were black. You could definitely do that here. It might be kind of tricky to interpret, but it is possible. I would need more context though to recommend or not recommend it. Let me see what other questions is. Oliver asked, does ggplot do 3D or interactive plots, or is that a different package? No idea, but again, when there's a will, there's a way. I'm sure you could do it. However, R is, after all, a statistical software, not necessarily like a mapping one or a GIS software. I know ArcGIS is like a popular map software. So if you really want to get into the weeds, I might recommend that, and I am not the right person to ask. But it would be very cool. I when I do waste time, I spend a lot of it looking at Google Maps and Cotrex, which is the greatest hiking app of all time. But let's see. I'm going through the questions.
You've covered everything that I've seen in the chat.
Okay, cool.
But if there's any other lingering questions of material that Matt covered today, or questions of things you hope to have covered in the future, feel free to type that in the chat or unmute yourself. Again, a reminder to fill out this survey link I put in the chat. That will enter you into our raffle, and we really do take all of your feedback into designing each year's Data Week.
As a final thing for the people who are still here, I wrote at the bottom my final thoughts. You can make all of these plots yourself. ggplot2 skills are actually just Googling skills or chat GPT if that's more to your speed. I didn't know anything about heat maps or regular maps before this presentation and just figured it out because I thought people would be interested in it. And everything before that, those components of the presentation, I had also learned from Googling. It's just you got to figure out the right words to ask and the willingness to goof around in R. And the world of ggplot is your oyster. So that's all the encouragement I'll leave with that. Lauren can tell you, she just started doing R recently. It's now an R wizard. So yeah, she's much better at SAS than I am, though, and I'm afraid of SAS. So we'll give her credit for that.
Well, you can join my macros session tomorrow at noon.
I could. Any other questions? Or should I just stare at all the blank screens until the end? Oh, yeah, Elizabeth, yeah, hang out if you want to ask. I don't have anything at 1, so unless Lauren kicks us off, we can chat as long as you want.
I'll just stop the recording and you all can keep asking away.